Good morning, class. So you guys have written a test. At this point on, we are busy with wrapping up general solution from the graph section from chapter 6. So at this point, you guys had homework. It was exercise 6.7, 6.9. You understand, yeah? So you can see. Listen, if you guys don't come second break, no? I'm going to keep you on a Friday for 2 hours then instead. Okay? So you must make a choice. Don't let me wait for you. Are you going to stay Friday for 2 hours? From 2 till 4? Michael? You are rather going to take your attention on Friday for 2 hours. So please be a second break, okay? Where are you going? Stop walking around. Okay, it was 6.9. So need to get 6.9. 6.9. That was on page? Sorry? 214. 214. Okay, so again I'm just going to do the odd numbers. And then you can let me know what the issues are, if there was any of the other even numbers, okay? So exercise 6.9. and 214. Okay, so we're going straight into number 1. Okay, so here we are told that cos of x is equal to half. So if cos of x is equal to half, my reference angle is going to be our cos of half, which is 60 degrees. Or they could have told you without using a calculator. So without using a calculator, since we know that this will come from a special triangle. Okay? That's how we know that your angle will be 60 degrees. So the question we should ask ourselves, in which quadrant is cos? Positive. Not so. So in which quadrant is cos positive? Quadrant 1 and 4. So how do we get in quadrant 1? It's just the angle. So x equal to 60 plus k times 360. Or x is equal to, in quadrant 4, 360 minus 60 plus k times 360. So that's going to give us 300 plus k times 360. Where k is an element of integers. Now since there's a restricted domain on this equation, we're going to say x is an element of, and we start listing. Okay, we'll start with k is equal to 0. We always start with k is equal to 0 then. So that will give you 0, so it's 60 degrees. If k is 1, there's going to be 60 plus 360, which is 420, which is outside the given domain. So we go with minus 1. So 60 plus negative 1 times 360 is negative 300. Not so? And again, if we put minus 2 where we find k. So that is going to give you negative 660 degrees. If you want to go with minus 3, it's definitely outside, lower than the lower boundary. Smaller than the lower boundary. Now we go to the other branch. If I put 0 in k, I'm going to get 300. I'm going to put 1 in, I'm going to get 660, which is again outside. Okay? Now at this k, we're going to put now minus 1. Put minus 1 in, I get negative 60. I put minus 2. Put minus 2 when you find k, you're going to get negative 420. Is that correct?
Yes.
If I put minus 3, it's going to be way below. Not so? And there's my solution. Okay, any confusion yet? Yes?
If you leave out just one value, the row can be wrong.
Sorry?
If you leave out
One value, lose one more. Okay? Yeah. But you see in the exam, we won't give you so many. Give you like 2, 3 values. So we give you one mark here, 1. And then 3, say 3, 4 on your solutions. Okay. So it will be like 4 or 5 marks. Okay. Sometimes we give you 2 marks for one solution. It depends how easy the sum is. No? It's a complex, and then the sum is complex, we give you more marks if it's like just row to work, easy work, and then of course we just can't give you a mark for every statement. So let's look at number 3. Number 3, you got cos of x equals negative root 3 over 2. Now here's no restricted domain, which means to say I must find the general solution only. Not so. Again, that is a special triangle, not so. That is going to be 30, 1, 2, root 3. So cos of 30 is root 3 over 2, so that x angle is going to be 30 degrees. Okay. So what do we ask ourselves at this point? In which quadrant? It's cos. In which quadrant is cos? Negative. In which quadrant is cos negative? 2 and 3. How do we get into quadrant 2? So it's going to be x is equal to 180 minus 30 plus k times 360. So x equal to 150 plus k times 360. Or in quadrant 3. How do you get in quadrant 3? 180 plus 30 plus k times 360. So x is 210 plus k times 360. Where k is an element of integers. Again, if we leave that k is an element of integers out, we're just going to lose the mark. Okay. Any confusion here? Number 5. Number 5, again, the restricted domain. So we can say that your reference x and the reference 3x is equal to. Now that's again a special angle. So that's going to give you 60 degrees. Not so. So the question you should ask yourselves, in which quadrant is cos positive? So 1 and 4. How do we get in quadrant 1? How do we get in quadrant 1? Just the angle. So it's 60 plus k times 360. Not so? So you divide by 3, so x is equal to 20 plus k times 120. Or quadrant 4. How you get into quadrant 4? It's going to be 360. Remember that's 180 minus 180 plus 360 minus, so just the angle. Okay. So quadrant 4. So 3x is equal to 360 minus 60 plus k times 360. So that's going to give us 300 divided by 3. 100 plus k times 360. So k is an element of? Indeed, yes. Divide, yes, that's actually k1, 3. Thank you. So theta is an element of 0 to 360, so x is an element of. So when we see k, we put the 0 first. First branch, we give it 20. Now we go k is 1. So we're going to get 140. If k is 2, it's going to give you 260. If k is 3, it's going to give you 380, which is outside the given domain. If I put minus 1, we have to see k there now, get negative 100, which is lower than, or smaller than your lower boundary. Not so. So let's look at the second branch. I put 0 in by k here. I'm going to get 100, which is within our within the given period. If I put 1 by k, I'm going to get 220. When I put 2 by k, I'm going to get 340. I'm going to put 4 by k, it's going to be outside. If I put negative 1 by k, I'm going to get negative 20. So there we go. Okay. Number 7, another restricted domain in question here. So again, we must find our general solution first. Okay. So what do we need to do first here? Divide by 3. So cos x is equal to 1,62 over 3. So what do we do now? Reference x, so you've got r cos of 1,62 over 3 gives us an angle of, so r cos of 1.62 over 3, that's 57,32. 57,3 degrees. Okay, so the question that comes to mind is which quadrant is cos? Positive. 1 and 4. So quadrant 1. So x is equal to 57,3 plus k times 360. Or quadrant 4. X is equal to 360 minus 57,3 plus k times 360. Okay, so that's going to give us 360 minus that answer, 302, comma 7 plus k times 360. K is an element of integers. Right, so what do we do from here? We need to list because it's restricted domain there. So what do we have? X is an element of. Start listing. Put 0 in here. I'm going to get 57,3. Okay. Put 1 in. So it will be outside. Not so. Put negative 1 in. I get negative 302,7. Is that correct? Right. Put negative 2 in is way out. Put 0 in. I'm going to get 302,7. Put minus 1 in. We're going to put 1 in, is going to be outside. Put minus 1 in, is going to give you negative 57,3 degrees. Put negative 2 in, it's going to be lower than, smaller than your lower boundary. Okay, any confusion there? Right. So that was up until question 7. Let's go with 9. We're looking at number 9. We got 3 cos 2x minus 10 minus 2 equals 1. Again, you got the restricted domain. So x is an element of negative 270 and 180. Okay. So where do we start first? We need to isolate the trig ratio. So we say cos of 2x minus 10 is equal to, take 2 over, it becomes 3 plus 2, which is, 1 plus 2, which is 3. Then I divide it by 3, which gives me an answer of 1. Not so. So if this cos of or sine is equal to 1 or minus 1 or 0, what I do is I take it to the graph. You don't have to, but I think this is a very nice way to look at it. So where is cos equal to 1? Is 1 at 0 degrees and at 360. Now 360 and 0 is the same. Okay? So I just need to write it once then. So my reference 2x minus 10 is equal to 0 degrees. Okay, well our cos of 0 is 1 anyway. So we will know that this solution repeats itself every 360 degrees, not so? And from 0 to 360 it has basically one solution. It has the 360, but as I said, 0 and 360 is the same. So to represent this, it will simply be 2 cos minus 10 is equal to 0 degrees plus k times 360 degrees. Why? Because at that point it's going to hit every 360 degrees. So here we take 10 over, becomes 2x is equal to 10 plus k times 360. Then I divide by 2, so I get 5 degrees plus k times 180. Where k is an element of integers. Okay. Now coming back to the main part of it. So we have to say x is an element of, and we start listing. If I put 0 in here, I'm going to get 5 degrees. If I put 1 in, I get 185, which is outside, not so? Yes? Sorry? Well, what would it be in quadrant 4? What would it be in quadrant 4? Huh? You're going to be the same answer, same solution. Yeah. So you put 0 in, so I get 5 degrees. If I put 1 in, I'm going to get 185, which is outside. Now I put minus 1 in, which gives you negative 175. Not so? Put minus 2 in, what do we get? Negative 355, which is again outside. Not so? So there we go. Those are the two solutions. Okay? You all agree with that? Is it right? Huh? Yes? Okay. Number 11. So we've got 4 cos 3x plus 3 equals 0. So cos 3x is equal to negative 3 over 4. Okay. So what we do now, we drop the negative. So we say reference 3x is equal to r cos of 3 over 4. So r cos of 3 over 4 gives us 41,41. So I square 41,4 degrees. So what question comes to mind? In which quadrant? It's cos negative. So in which one quadrant is cos negative? Sorry? 2 and 3. So how do we get into quadrant 2? So it's 3x is equal to 180 minus 41,4 plus k times 360. So you say 180 minus that angle. Then we divide it by 3. You get 46,2. 46,2 degrees plus k times 120. 4. So right? Or 3x is equal to 180 plus 41.4 plus k times 360. So that would simply give us 180 plus 41.4 divided by 3. Whoops. Which is 73,8. Is that correct? Is that correct? 73.8 plus k times 120. K is an element of integers. Again, there's a restricted domain in this question. No, there isn't. So, that's your solution. Okay? Number 13. So firstly we're going to take the 3 over. It's negative cos x plus 20 equals negative 0,6. Not so. Now I divide by negative 1, so then cos x plus 20 equals 0,6. That is 3 over 5. So you've got r cos of 0,6 or 3 over 5 gives me a reference angle of 53,1 degrees. Question that should come to mind in this: which quadrant is cos? Just before we apply the arc cos, it was positive. So we ask ourselves which quadrant is cos positive? 1 and 4. So for quadrant 1, it's going to be x plus 20 equals 53,1 plus k times 360. So x is equal to 33,1 plus k times 360. Or, on the other hand, this will be x plus 20 equals 360 minus 53,1 plus k times 360. So x is equal to, what does that work out to be? Sorry? Negative? No.
Positive.
Yes? 286. Yeah? 9 plus k times 360. Okay. Now coming back to this domain here. So that will simply give us x is an element of, start listing. Put 0 in here. I'm going to get 33,1 degrees. If I put 1 in there, it's definitely outside. Not so. Put negative 1 in, it will be lower than negative 180. Not so. So let's go on the other branch. If I put 0 in here, it's 286,9. That is again outside. If I put negative 1 in by k, I'm going to get negative 53,1. Is that correct? Is that correct? If we're going to put minus 2 in, it's going to be way below. Okay? So now you guys can do the even numbers for homework. No? Did I give you only the odd? Okay, now you do the even numbers for me. Okay. Then I'm going to do 2 or 3 out of this exercise. Yes? 6.10. Yes, I'm getting there. So what I said was I'm going to do 2 or 3 out of here. Okay, so what I'm going to do is I'm going to do the examples. I didn't do the examples of the other one, no? No, okay. Let's just go straight into 6.10. And 6.10 was on page 215. 6.10 on page 215. Now I asked you to do the odd numbers, not so? Right, so let's look at the odd numbers quickly. So for number 1, the sum of tan of x is equal to 5,325. Okay. But the question has also a restricted domain there, where x is an element of negative 360 to 360. Okay. So again we go with restrict the reference angle. My reference angle is going to be x is equal to arctan of 5,325. Arctan of 5,325 gives us 79,36. Is that correct? So 79,4. Right. So which question comes to mind? In which quadrant is tan positive? So in which quadrant is tan positive? First and third. So if I go with that, it's going to be quadrant 1. X is equal to 79,4 plus k times 180. Not so. Why k times 180? So the period on the tan graph is 180. Not so. Or in quadrant 3, it would be x is equal to 180 minus 79,4 plus k times 180. 180 plus, yes. This gives us speaking? Speaking. Mijn is net klaar met van jou apostolic, please. Okay. Thank you. Alright, so this gives you 259,4 plus k times 180 degrees. Not so? So here you see there's a restricted domain here. Not so? So let's go with that. So you say x is an element of. You start listing. Put 0 in here. I get 79,4. Okay? 79,4. If I put 1 in, what do I get? 259, 259, 4. If I put 2 in, what do I get? So it would be outside now, not so. So what do I do now? Put minus 1. If I put negative 1 in, what do I get? Negative 100,6 degrees. If I put minus 2 in, what do I get? Negative 280,6. If I'm going to put minus 2 in, what do I get? This one, huh? Sorry, minus 3. Outside. So do I have to write that? No. Now if you look at this branch here, if I put 0 in here, what do I get? 259,4, which is that one. Not so? So if I'm going to put 1 in, I'm going to be outside. Not so? If I'm going to put minus 1 in here, I'm going to get 79,4. You see that? If I put minus 2 in there, I'm going to get negative 100,6. If I'm going to put minus 3 in, I'm going to get 280,6. If I'm going to put the next number in, then it's going to again be outside. So what does that mean? That means you say that this solution here and this solution is the same. You see, there's a whole lot of repeated solutions here. Okay. The reason for that is because if you look at the tan graph, the period of the tan graph is what? 180. And for you to get from quadrant 1 to quadrant 3 is how much degrees? Also 180 degrees. That is why it's a repeated solution. So if you go this way, if tan is negative, it was going to be quadrant 2 and 4, not so. Then how much degrees later is that? Also 180 degrees. So for the tan graph, you need only write one branch for the tan graph. Make sense? Yes, Michael, your hand was up. As I said now. Oh, your hand was up before. Okay, so you must give me a chance. How are you then? What kind of girl are you then? It doesn't matter which one we write, but I would go, if it's positive, I would represent it in the first quadrant. If it was negative, I would represent it in the second quadrant. Okay? Sorry? Okay, is an element, yes. Which means to say I would have lost the mark there. Okay, let's going to do one quickly, one more. Is that okay?
Yes.
Number 3. Okay, that was a general solution. For number 3, you got 2 tan x over 2 equals negative 8,345. So that's a general solution. So what do I do first? Divide by 2 both sides. So tan of x over 2 gives us what? Negative 4, 1, carry 1, 7, 2, or 3. Not so. So what do I do now? I say reference. X over 2 gives us, I say arctan of 8.345 over 2. Okay, what's 76,52? 76,5 degrees. So which question comes to mind? Which quadrant is tan? Negative. So it's tan negative in 4 and 2. So which quadrant do I represent it in? 2. So we say x over 2 equals 180 minus 76.5 plus k times 180. Not so? So that gives us 180 minus that answer. Gives us 103,5. Not so? What do I do now? I multiply throughout by 2 to get rid of the fraction. So it's 206,95. So it's 207. So x is equal to 207 degrees plus k times 360. So throughout you must multiply by 2. You understand? Now, you see sometimes the textbook has a negative answer. I don't know if that's the case here. Is it negative? Sorry? Is it negative or positive at the back? Negative or positive? Negative. Is negative some value? Now, sometimes different textbooks explain differently. No? Sometimes they use negative. Now, we only use positive angles because we have a positive outlook on life. No? Right. So what we do to check if we're correct, what we do is you take this, whatever that value is, then you minus it by that value. So in that case, it's going to be 207 minus 360. So the answer should have been negative 153 plus k times 360. Does it make sense? And that is how it is, people. Alright. People, enjoy the rest of your day. For homework, I would like you guys to do 6.10 on page 2.15. You do the remaining sums. So during tomorrow's lesson, I'm going to look at number 5 as well. Alright. Okay, good morning, class.